Hello all. Hello and welcome to this evening's edition of the Build Tech Talk. This evening will be all about building serverless applications with the Google Cloud Platform. And our speakers will tell you about two services from Google. The first service is Firebase, and Bart Kooijman will talk about what it means to build web apps with this service. This will make the life of the developers so much better, because Firebase will give you tools that cover a part of the services that developers normally would have to build themselves. And not because they want to, but because they need it for their daily work. The other service is Google Cloud Run, and we will get an introduction about this by Wietse Venema. He will leave us with a high-level understanding and a demo. Bart and Wietse work together at the project, and they are both very good at capturing your attention while they talk about their passions. Before I forget, if you have any questions during these presentations, please put them in the chat, and I will pass them to the speakers at the end of the presentations. Now, let me introduce you to our first speaker, Bart Kooijman. Hello, Bart. How are you?
Hello, good evening. Yeah, I'm doing fine. I'm doing great, actually. Great to be here. My first BLD, or first Build Tech Talk.
Nice. And what keeps you busy these days?
Yeah, well, of course, my hair. Apologies for my very bad haircut, but I think a lot of people out there are suffering at the moment from similar kind of issues. It's a bit long, of course, at the moment. But seriously, I think, at the moment, what I'm currently busy with is a lot of Google, and in particular, my home budgeting app. And what that will be exactly about is, what I will be talking about in the next 45 minutes or so.
Okay, well, let's go there. The floor is yours.
Sure. Okay, thank you. So, good evening, everyone. For those of you who don't know me, my name is Bart Kooijman, and tonight I'm going to tell you something about Firebase, which I've been playing around with for the last couple of months as a side project mainly, because normally I work for clients of Capgemini, mainly in e-commerce and digital marketing. Here's the agenda for today. Who am I? I will shortly further introduce myself. We'll talk a little bit about, let's say, my period in web development so far, which is already well over 20 years. And then, of course, we'll dive into Firebase. And the way I got to learn Firebase is basically by building something with it. For me, always the best way to learn new stuff is just by building something with it and, get your hands dirty. And that's basically what I did with my budget app. And of course, I will also, after sharing my learnings with you, talk a little bit about what it's best used for. Because I think after seeing the way that I used it, it makes a bit more sense to do that at the end. So, as I already mentioned, I've been doing software development and web development in particular for well over 20 years now. I went from Java programmer to, as I call it today, doing both front-end, back-end, and actually also everything that's needed to set up the build pipeline and deploy everything to production, which is, of course, nowadays something that has become relatively more easy than it was, let's say, 20 years ago when I started, thanks to the cloud. Question then always is, in what kind of areas do I build? Well, in my case, it's mainly digital commerce and digital solutions that I build. Customer-facing, customer of the customer in this case. In my spare time, as you can see here on this picture, I fly gliders. So if this presentation is boring to you, then there's always one key takeaway, and that's that I can always offer you the opportunity to come and fly with me or my fellow pilots at the Glider Club in Biddinghuizen, Zet-Zeeflevo, where you can see the Netherlands from above if you want to. We ask a small fee, but by paying that fee, you support our club, to continue doing what it's doing at the moment, which is, of course, flying gliders. So 20 years in IT. People then start to ask you, what is it, Bart, that in those 20 years changed the most? And to be honest, what really changed the most is, of course, let's say the importance of software. That really changed. But hand in hand with that, basically came a big transition from moving from, let's say, the waterfall kind of approach to the now what we nowadays call DevOps kind of approach. Back in the days when I started, we got these thick documents coming in describing what the software would have to do, and then let's say in a couple of months later we had to deliver it. That has changed from let's say that time constraint kind of working more towards the strategic long-term kind of way, and also the focus from, let's say, being on time and meeting the budget and the agreement went to business value. And also what really changed is that we went from requirements to desirements. We came to realize that software development is a really complicated activity. And as much as we think about the requirements up front, we usually don't always get them right the first time. And by accepting that, we needed to have this same different kind of model, different kind of way of working. And remarkably, while you would expect that if you are, let's say, in a waterfall kind of project, you would expect that there's a lot of focus on productivity, the deadline. But from my experience, what you see is that actually on the right, the focus on productivity is even higher by applying, for example, lean principles, taking out waste, making sure you have small batches, working in small increments. And it's this shift, this massive shift, that also has fueled a lot of, let's say, evolution into the technology as well. It came along with it. Back in the days when I started, it was normal that you had to wait like a couple of months before your server arrived. But thanks to, let's say, virtualization in the early 2000s, and of course, the first infrastructure as a service kind of solutions, all the way down to, let's say, cloud native, where we are at right now, this has changed dramatically. Especially infrastructure is, let's say, the second biggest change that I've seen happening, and especially, of course, fueled by the public cloud. And it went all the way down further, even by combining also the middleware into the infrastructure, platform as a service, and eventually what we nowadays call cloud native. The combination of having, let's say, a microservices-based architecture, deploying them into containers, combined with a DevOps way of working and continuous delivery, and of course the corresponding platform that can actually orchestrate and run those containers. And yeah, that's where we of course see Kubernetes a lot. However, things are of course not standing still here at this point in time. Moving further. And one of the things that has come along with it and is sort of building on top of cloud native and especially on Kubernetes even further is the whole idea of serverless. And in fact, we have now for the first time reached a point where you can just say, here's my code, here's my data, and I can hand it over to the platform and it will do the rest for you. Now, coming from where I came from 20 years ago, this is really a big step forward, something we could only dream of back in those days. Not that it didn't already exist. Of course, when you talk to veterans, they will tell you that there were some platforms that could already do it to some extent as well. But let's say for the web, as we can do it now with serverless, it's really a massive step forward again. Sure, there are still servers involved, but you just don't have to manage them anymore. And what's really nice, of course, and which is something, of course, the cloud has also brought along with it, is that you truly pay for what you use. In the past, with infrastructure as a service and with platform as a service, you were seeing that you still had cost models based on, let's say, the time that you use it. We're now getting close to or having actually a payment model based on the request. And what's even nicer about it is that it also easily scales up and down without you having to take action. It can even scale down to 0. And it was actually this scaling down to 0 that really got me interested into Firebase as well. Because it means that if my app isn't used, my cost is 0, and I don't have to worry about shutting down my side project. But it's not only, let's say, serverless in the sense of functions, because usually the first thing that people think about is function as a service when we talk about functions, or when we talk about serverless, I mean. But it's also about database as a service, serverless databases where you also don't have to worry. So, for example, DynamoDB, or as we will see later in this talk, Firestore. But also Azure with its Cosmos DB. But also keep in mind that if you store something in an AWS S3 bucket, you also don't really have to worry about how it's getting stored, how it's getting persisted, where it's getting persisted, how many servers are needed. And if you even upload, let's say, a terabyte of data to S3, how it gets distributed across disks and all that kind of stuff, it's all transparent. It's all abstracted away. Because that is, of course, also what I learned in those 20 years. If there is a problem, abstract it away. Abstraction layers on top is what sort of is the key here in solving IT problems. But also messaging is also nowadays much more serverless. Or actually, already when AWS was launched back in the days, SQS, its first service was in essence already serverless as well. Pops up then for Google, same thing. And of course, your hosting with CloudFront, Cloud CDN, Azure CDN is also something where you don't have to worry about how it actually gets done in detail, especially in terms of server. Now, so a lot has changed over the years, and especially now with serverless being here. And you basically now see that you have, let's say, a number of solutions available in each and every public cloud that are named serverless. And what Firebase actually did is combining them, and by creating, let's say, a new serverless kind of platform to host your app with. So meet Firebase. So Firebase is basically a set of services and tools that can help you build web and native apps. It started in 2011, initially mainly as a mobile backend as a service. So it was focused initially very much on creating native apps. So of course for the two main platforms being Android and iOS. But along the way came also the support for web apps. So it broadened its scope a little. It's built on top of and integrates with Google Cloud Platform. And what that exactly means, we will see further down the line. And what's really interesting about Firebase and one of its let's say unique selling points that it has been advertising with is that it's real time. It has real-time databases, meaning that if something gets updated by client A in the database, it gets immediately reflected in client B if it's looking at the same data. There's plenty of support for, of course, Android and iOS, but also Unity is supported. And there is also support for C++. And that's mainly to also have Firebase serve as a backend for games, if you want to. And of course, the web. And if there are certain solutions missing in the set of services and tools that you already have, there's always Firebase extensions that you can nowadays also look into, which is, for example, containing solutions to enable you to make payments in your app. So there is an integration or an extension for Stripe, and I think already one for the big Dutch payment company that recently went public, and that I'm now quickly forgetting the name of, but you sure all know. And what's also nice about it is it has a generous free tier. You can really use Firebase for your MVP. I would really recommend doing that because, then of course, if you only have a few users, good chance are, depending on your design, that you can use it to a large extent for free for your first initial set of customers. Okay, so what are these services, and tools that they provide exactly about. Firebase has categorized them. They are categorized now into 3 categories, being built. So those are the tools and services that you need to actually build something. Release and monitor, which are services focused on mainly monitoring and also to some extent testing and distributing your app. And finally, also a category called engage, which is more about, let's say, the experience that you will get from your app once you have installed it. Now, as you can see here, I've highlighted a few services. And the reason why I did that is because those are the services that you can use for your web application. I stayed away from everything that's, let's say, native, because my home budget app that I will talk about in a few minutes is a web app. So I can't really tell, let's say, how the other services work for native apps. Also, I will focus on, of course, the build services. To quickly highlight, in the release and monitor section, you can see Google Analytics. Now, Google Analytics is, of course, a well-known product if you want to track the user behavior in your app for both web and native. Google Analytics, I think, is probably the most used analytics tool in the industry. What's also nice about it is performance monitoring. Firebase nowadays also supports performance monitoring, and what's nice about it is that it gives you real-time insight into some of your key metrics. And what's nice about these key metrics is that they are not the usual kind of performance metrics that they use. They are using more, let's say, the more modern experience metrics. So time to first paint or speed index, those kind of metrics you monitor with this. And at the client that I'm currently working for, we managed to implement performance monitoring from Firebase on a website that wasn't used on Firebase, that wasn't running on Firebase. So if you think, I'm not sure if that's something that you can still use for free, but it's worthwhile maybe also for your project to investigate if you can actually roll this out. But we'll focus for the remainder of this talk on the build tools, because of course building with these tools, they are mostly all serverless. Of course, it's interesting and easy to work with, and it's the tools that I use to build the app that I made. Before I do that, I first want to quickly show you around in Firebase as well. I'll show you also what it looks like so that you get a better sense of how these services expose themselves. And basically how they do that is via this dashboard. So here you can find the build service, the release and monitor services, and the analytics and engage services. Here, for example, you can see authentication, which I'll talk about shortly, where you could, for example, add some users. Here you can also see functions. Here you can see the performance solution that I was just talking about, and many, many things more. But as said, I wanted to focus on the build tools. So what, let me quickly go back to went. So my budget app. As I said, my budget app, the idea behind it was to create an app to actually get myself acquainted and learn about Firebase even more. And of course, everywhere in the world, there are already plenty of home budgeting apps that you can find. So my purpose certainly wasn't to create one that would conquer the world of finance apps. It's really just, how do you then start with Firebase if you want to create a web app? Well, the first thing you see that you need to use is Firebase hosting. Firebase hosting is basically behind the scenes, of course, the Google Cloud CDN and some other solutions from the Google Cloud Platform itself. But again, that's not something we really have to worry about. For us, Firebase hosting is basically the place where you store your HTML, CSS, JavaScript, and other static assets, as we sometimes refer to. So then the second step is, of course, to make sure that you actually have those assets. And what I did in this case, I created a Vue application because I like Vue. It's a nice framework. It's a nice web framework to create these kinds of apps with. And also Vue comes with what they call Vueify. And Vueify is a library on top of Vue, which has excellent support for Google's material design. And since I'm quite a fan of material design and it makes my apps look quite good, and I'm not a UX designer, or at least that's not my specialty, it's, let's say, for me, the best way to come to a nice looking app. Then you have to install the Firebase CLI. And the Firebase CLI is basically the tool that helps you interact with Firebase. So if I show you then my home budgeting app project, it will probably look familiar for especially those of you who are front-end developers. You will see here that, let's say, there's the usual public directory where, for example, your images and your favicon file is, and maybe if you want to, your robots.txt, and you will have your source folder where you can find your Vue assets, so your components, that kind of stuff. So it looks pretty familiar. The CLI is something, it's basically a tool that you install npm. It's very easy to install. And as said, it gives you all the different commands that you need to interact with Firebase itself. One thing that was a bit challenging I learned is while setting this up, you have, let's say, the Firebase CLI installed, which is actually running a so-called emulator if you want to. So if you are doing local development and you want your web app to communicate with build services from Firebase, they provide you a local emulator so that you don't have to talk to a real Firebase that's running live. So the Firebase environment you have created at Firebase itself. But the emulator and the Vue CLI are two different servers. And your app is actually running on the Vue server. So you have to make sure that especially the Firebase SDK that you need to have your app communicate with Firebase as well needs to be proxied. So you have to jump through some loophole here and pull the trick to make sure that, let's say, the Vue server proxies the request for the SDK to the emulator, where the SDK is actually. So that was one of the things that I learned and fixed. And then you can still combine your Vue CLI-based app with the emulator. All the other services of Firebase in the emulator are running on different ports, so they can be easily reached by your app locally. Some additional features, if you want, with Firebase hosting, you can, for example, deploy a preview to your Firebase environment first before making it the real one, before making it, let's say, the production one. It has a feature called preview channels for it. And also can deploy via a GitHub pull request. And this is nowadays very important because this is sort of making it possible to use Firebase for your Jamstack project as well. Now, what Jamstack exactly is not something I'm going to talk about in this presentation. But for those of you familiar, for example, with Netlify, it's a similar kind of concept. Or at least the concept is in the app itself. But if you are familiar with Netlify as a platform, Firebase hosting and Netlify sort of fall in the same kind of category when it comes to hosting. But also you can request, you can look into your request logs via cloud logging. You can implement rewrites, redirects, and there's even support for IE18N. So it's quite sophisticated hosting. And there is a special feature that I will talk about later. Going back quickly to, no, I'm not going back quickly. I'm going to the next slide. So also here to recap the story that I've been telling on the previous slide so far, you've got your GitLab, in my case, GitLab Git repo, where your code is located for your web app. You pull that into your local machine. You have a Vue server running to actually execute your code locally. You have the emulator running to reach all build services of Firebase. And then you have the CLI to perform, let's say, the interaction with Firebase itself. So the Firebase CLI is there to deploy, create a preview, all those kind of things. But also, if you want to export the data from your emulator, if there happens to be so. Okay, so now that we have, let's say, a web application, the next step is to make sure that, of course, for a home budgeting app, you need to be authenticated. And essentially, Firebase solves a lot of these type of typical app problems for you. So there's Firebase, and that's where, in this case, then Firebase authentication kicks in. So you create some users, and you initialize the Firebase SDK in your app, which you can see over here, which I did like this. Now, I did like this, so using the script tag in my index.html file is because by doing it like this, the hosting, Firebase hosting, provides me immediately, let's say, with the correct initialization settings. So it knows, let's say, what my app name is, and a couple of other settings that you need to provide in order to properly initialize Firebase, and also the SDKs, the additional SDKs that I'm using, including, for example, the Firebase authentication JDK or SDK. So when I run init, yeah, all these things get automatically set. This means that I don't have to create an initialization script for a test environment, a production environment, or staging, or whatever kind of environments you might be having. Because that's possible. You can set up multiple base projects per environment, let's say, depending on what your your environment strategy basically looks like, or your deployment strategy looks like. One thing that you also have to take care of when initializing is that, of course, your app might be talking to the emulator, and you still need some code into your to make sure that you talk to the emulator, as you can see here. I wasn't too happy about this. If it could somehow in the initialization figure this out so that I could leave this code out of my repo, and basically therefore also out of production. But okay, this is one of the things that they still need to, in my opinion, fix. So once that we have initialized, I created a login component where, of course, you take in the username and password, and then it's very easy. You just call the Firebase. There's a Firebase variable which has an auth method on it, which contains, let's say, the Firebase authentication API. And as you can see here, you just pass in the username and password, and then you can just let basically Vue do the rest of this thing and that kind of stuff. You can also see here that I'm calling the set persistence method, which makes sure that if you close the browser, the session gets killed. And you have to, again, log in. But you can also, for example, make sure that you stay logged in after opening the browser again, or even when you, or already when the tab gets closed, the session can get killed as well. So there are multiple options here that you can use. So yeah, you just create the users, a component with the login form as we just saw, and from there on it's actually a matter of just using the SDK. The SDK provides you even more functions or features if you want to. You can do social sign-in. You can also do phone number authentication. And there's even a complete component available that you can use to implement, for example, social sign-in immediately in your UI. It's called Firebase UI. I'm not sure if it's used a lot because I've seen quite a lot of comments on it saying that the UI is not as well designed as you want to. So you can always rely just on the SDK itself. But if you want to just quickly ramp up password recovery and those kinds of flows without have built all the front-end code for it, then you can just include this ready-to-use widget, as sometimes people call it. Okay, so let me quickly continue with from the current slide, that one I was looking for. And then, of course, you need to start storing things. So for my home budget app, the idea is that you, of course, need to store transactions. If you get them from your bank, if you download them, in my case, ABN AMRO, you get transactions without categories. So it doesn't know that when I visit the grocery store that the transaction should be categorized into groceries. So the first thing that I started with is making it possible to create and edit and delete category rules and store them, and of course reuse them when transactions were uploaded. And how to do that is by using Firestore. Firebase offers two types of databases: the real-time database, that's literally what it's called, and Firestore. Both are having the feature of, let's say, what Firebase calls real-time, that when you update a certain piece of data, it immediately gets reflected. But Firestore gives you some more querying capabilities. Firestore, both databases are based on JSON, so based on documents. So you have to sort of translate your, in my case, category mapping rules towards documents that you then store. You can do that directly from the browser. So here, for example, basically what you do is you initialize the SDK, but then for Firestore, and you create a collection where all your filters reside. And then in that collection, you can just add and remove pieces of JSON. And since Store is, let's say, your JSON can just be sent into it. You don't have to worry about whether it has to comply with certain consistency rules whatsoever. That doesn't mean that Firebase, or Firestore, I should say, doesn't have consistency rules. You can set them. And of course, since your database is out in the open towards the internet, it's of course also protected by security rules. And these security rules are very sophisticated, and you can use them to indeed check if somebody is authenticated before an update is taking place. But you could also, for example, check if certain pieces of the JSON of a certain type. So you can, to some extent, still enforce some consistency if you want to. It also has offline support. The SDK that you use in your app can be made smart enough and configured in such a way that if there's no internet connectivity, it will continue to function offline. And to improve query performance, there are indexes and also transaction support is possible as well. So if you want to make multiple updates to Firestore, that's possible too. There's also the possibility of batch updates. But while I was working on this and playing around with storing these categories and eventually also transactions, I learned that Firebase has some drawbacks. And for me, especially for something like our own budgeting app, it turns out that you run into these limitations quite quickly, because one thing that's really missing is aggregation queries. So if you're familiar with SQL, you have, for example, the sum and the average, those type of, let's say, functions also, they are missing in Firestore. So that means that if you want to, for example, know how much you spend in a month, if you store then and you want to know, let's say, what the average was you have spent on your groceries, you can't just let the database do that. You then first have to make sure that you get all your transactions that were, let's say, categorized as grocery, and then client side calculate what the average is. And you can easily imagine that, especially for the dashboard kind of capabilities that this app will have, this is something that you miss. Now, Firebase provides good documentation and also interesting presentations where they explain how you can solve that problem by basically not using your documents, let's say, as entities, but to start designing your documents more towards the UI. And for example, then create a document containing your average spending on groceries. So sort of pre-calculate that. But that's making it difficult. And especially you have to keep in mind that, let's say, the cost model of Firebase is per query. So read queries are a bit cheaper than update ones, but still you need to think about, okay, if I'm updating and I need to update multiple documents because I have multiple documents per, let's say, dashboard or per page or per widget or per functionality, then of course your update cost can go up quite quickly. So that's a bit of a challenge or drawback of Firestore. But it can be also solved to some extent using functions. So Firebase also offers the possibility to do functions, because you can also imagine that keeping all your logic in the browser, which is what we have seen so far, can be challenging. You sometimes want to keep certain logic private or secure. That's where you can then use functions. And functions are behind the scenes, basically Google Cloud Platform functions. There are two ways to use them. You can expose functions specifically for your app or use them for your app, or you can create functions that are accessible via HTTP, not necessarily through your app. So for example, as an API that you want to expose to the outside world. Now, the nice thing about using it in the app kind of way is that you get, again, a lot of typical app problems solved for you. So for example, if your function is called, who is calling, who's authenticated via Firebase authentication, and also maybe what role they might have. You don't have, and whether they have been authenticated at all or not, that's already something you don't have to worry about. You can test them again using the emulator, and since it's a function, it's indeed leveraging, let's say, the cloud native kind of platforms like Kubernetes behind the scenes, but that's all hidden for you. When you have created your function and you type in Firebase deploy, it gets deployed to Firebase, and somehow it creates a container out of it, and using cloud build, it deploys the container for you. That all happens behind the scenes, and you don't have to worry about it. One thing, for example, these functions can do is server-side rendering. They don't necessarily have to be used to expose like an API, a REST API, but you can also use them for server-side rendering with, for example, Express. And they can also, and that's actually what they were initially developed for, be used for, let's say, triggers on certain other GCP products. So for example, an update in Firestore might trigger a function, or the arrival of a message via PubSub. This is what they initially were developed for, but they have some limitations. For example, at the moment, they are only based on JavaScript. You cannot use any other language. And they are also proprietary. The APIs that you implement, the SDK that you talk to, yeah, you could argue about whether that's sort of like a vendor lock-in. Now, whether that's really a problem, I think nowadays for a lot of apps that are being built, it's probably not. And of course, you can also have it away in your code. But still, for some customers that I know, this can be a problem. But also, for example, the limited lifetime of your function. It can only run, I think, if I remember correctly, for 9 minutes. And also the CPU and the memory capacity of the function is limited. So there are issues.
Thank you, Bart. I don't know if you were finished or just your connection fell through. Well, I don't see Bart, so I think he has connection problems. We have a few questions in the chat, but I think it's best now that we start with the second speaker, and after the second presentation, we will try Bart again to ask him the questions from the chat. So about the next speaker. Our next speaker is Wietse Venema. Wietse is an author and a software engineer. He works for Bings.io, and one of his passions is explaining things for developers to help them enjoy their work more, and he likes to make drawings to explain the concepts. When you look at his Twitter, you find all kinds of drawings, and one of my favorite is the throttle turtle. Hello, Wietse.
Hi, Natalie.
Welcome.
I'm glad you like my throttle turtle. Some people think it's a bit too frivolous, but I'm a big fan of my throttle turtle.
Okay.
Yeah, so I hope we will be seeing Bart again, because it was kind of an abrupt stop. I mean, that surely wouldn't have happened on a serverless platform.
No, I think it was almost the ending of his presentation. But I think it's best to continue with yours and give him time to reboot or whatever. So, welcome.
Yeah, thank you.
I know your biggest project of 2020 was the publishing of your book about the Google Cloud Run.
Yeah, that was arguably my biggest thing in 2020, because I wrote most of it during a global pandemic with my kids running around because of the school closures, and writing that book has been a great experience so far. Yeah.
So that brings us to the question: what will be your challenge for this year?
My challenge. Obviously publishing a book with O'Reilly leads to all kinds of new opportunities, and I will tell you about some in the talk. So I don't want to steal my own thunder.
Okay. I have one more question. When I look at your Twitter timeline, I saw also a lot of Japanese in the drawings. What is that all about?
Yeah, so apparently Cloud Run is really, really popular in the Japanese community. So in the startup community in Tokyo. So I made a few friends there, and we're now working on a Japanese translation of one of my blog posts. And that involves trying to translate my diagrams as well. And that has been a challenge because in Japanese you don't have word boundaries like we have in English. So there's no spaces between words. So I will get this translation of a label on the diagram, and then I will need to figure out where to break the word if I want to put it on multiple lines. Yeah, so a really nice experience to figure that out.
Okay. Well, let's go to your talk now.
Yeah, sure. Yeah, so before I head full into the talk, I want to explain Google Cloud Run in one diagram and tell you why I, as a software engineer, am so excited about it. And that's because the developer workflow is a straightforward three-step process. So first, you write your application using your favorite programming language. And the only requirement there is that your application should start an HTTP server. And then second, you build and package your application into a container image. And finally, you deploy the container image to Cloud Run. And then once you've deployed your container image, you'll get a unique HTTPS endpoint back. So that means you don't have to manage HTTPS yourself. Cloud Run then starts your container on demand to handle incoming requests and ensures that all incoming requests are handled by dynamically adding and removing containers. As a software engineer, it's hard not to get excited about this, right? Because this is a process that lets you focus on writing your code, making a great application, and not the infrastructure that runs underneath. It will be like, here's my code, and then go ahead and deploy, run, and scale that for me, because I don't want to know how many servers you use. Just make sure that it runs right, and that it handles all the traffic that I can throw on it. Yeah, but before I tell you more about Cloud Run, I want to also tell you a little bit about me. So my name is Wietse Venema, and for international listeners, my name is pronounced like we, like in the English we. We go to the park, we. Wietse. So with that out of the way, I'm a software engineer by trade, and I'm also a trainer at Bings.io, and we are a cloud-native IT services company in the Netherlands, and we are strong in engineering, training, and digital transformation. And we work with all public clouds, Google Cloud, Amazon, Azure, and Alibaba. So I like to draw diagrams to explain things, and I'm sharing those on my LinkedIn and Twitter, as Natalie showed. So I will be sharing them in the feed, the links. So feel free to connect with me or follow me. Yeah, and I'm from the Netherlands, as you might have guessed from my accent, which means you can ask me everything about Cloud Run and about bicycles. I counted this morning, and as a family of 4, we own 10 of them. I have a lot of bicycle jokes. I won't do them all for you. So one more thing, super important, and people confuse this a lot. I am not the famous Wietse Venema. That's the guy who created Postfix and now works for Google. So that's super confusing if you're also contracting for Google Cloud. People pull him into your Google Docs all the time because he is wietse@google.com. Well, that's not me. I'm this one, the non-famous, but well, the renowned author one. Yeah, so about that book. This is my main professional accomplishment in 2020. I wrote the O'Reilly book about Cloud Run. And well, when I said in the introduction that I wrote it in the middle of a pandemic with my 2-year-old and 4-year-old running around, the last part was a lie because I wrote most of it after 10 p.m. when everybody was sleeping. I'm a first-time author, and this has been an epic learning journey for me. And the best thing is that people really like my book. And to be honest, that's quite a relief if you've just spent 2 solid years creating something. And here's Kelsey Hightower. He's a well-known person in our community, and he wrote the foreword to my book. And this is his leadership has been an inspiration to me and to many others in the tech community. And this is what he wrote. This is in the book. I've onboarded thousands of customers, and I wrote a framework to help Go developers build Cloud Run applications faster. And even I learned a thing or two from this book. What took me 3 years to learn, Wietse delivers in less than a dozen chapters. And as you can imagine, I'm super, super proud of this achievement. But like, what makes me even more happy is that people are actually buying my book now and using my book to do their jobs. And Simon here is looking forward to using it in his upcoming products. And Silvio wrote me to tell that my book has a real impact on his day-to-day projects. And there's another thing that that resulted from writing this book, because I'm now also working with Google Cloud to build the new application development with Google Cloud Run course. And in a way, the very session you're in now is a sneak preview of one of the modules in the training course, as the content is inspired by my work on the course. So about this session, coming out of this session, you will understand how Cloud Run compares to other compute platforms on Google Cloud. It will help you understand what workloads might be a good fit and the ones that aren't. And assuming that I don't run out of time, there's a demo at the end and time for questions. About questions, if you have questions, this has been mentioned before, but please pop them in the comment box. I will monitor it during my presentation and answer them on the spot if it fits the story. But I guarantee you, I will come back to them at the end. Yeah, about that comment box, it's up to there. Open it and tell me something about you. Let me know where you're from and well, your country, your city, and your role, please. One question already. While you were typing, I will answer Sietze's question, because he asks me, do you get to pick your own animal? The answer is no. I didn't get to pick my own animal. So that's they pick it for me. And the rumor goes that if you start like asking for them to that you can, as an author, can pick the animal, then you will get a very ugly fat fish or something else. And this is just a rumor. I can't confirm it. But there's always a story behind the animal, right? So my book has a bird. So yeah, well, that makes sense because it's in the cloud. The Dutch name is lepelaar, and that's a bird that you will see a lot in the Netherlands and not really somewhere else. So that's the second thing. And then there must be a third reason, but I didn't uncover it yet. So if you figure it out, let me know. I will be very happy, because that's also something that you don't tell. They don't tell you. So I'm waiting for those locations in the comment box. Please share it with me. Hello from Amersfoort. Hey, that's where I live. Utrecht, Den Haag. Wow. Do we have any international visitors? I had people from Brazil and Vietnam. I mean, the whole COVID thing made, I don't know, people are much more used to visiting online events, it seems. Belgium. I think it's a bit too late for India. It's a lot of visitors from the Netherlands. But any case, if you're looking at the recording, that this won't make sense. So I will keep it short. But hey, good to know. Yeah. So let's head into the talk. Oh, more Sweden. Yes, we have an international visitor. Israel. Oh boy, I love this. I had a guy from Vietnam last time, and one from Ivory Coast. I had French in high school, and they convinced me to do this talk in French. So I'm practicing my pronunciation now. And there's a lot of firewalls in France, and then they connect the words when you connect them. That's une liaison. Anyway, I won't keep you any longer. Let's start by introducing you to, or refreshing your knowledge of, containers. Well, let's first start with the structure of a container image. A container image is a package with your application in it, along with everything that it needs to run. For example, in a container image for a Java application, your application is packaged together with the appropriate Java virtual machine. Okay, that might still sound a bit abstract, so let's zoom in a bit further. this is a good way to think about the container image. It's an archive with files, and those files include system libraries, executable programs, data files, such as for any web application, HTML files, images, binary blobs. And if you use an interpreted language such as JavaScript or Python, your application source files might even be in there because, well, that's what your application needs to run, right? All right, so in the rest of this session, I'm talking about container images and containers. And both are different concepts, so it makes sense to define them. If you run a container image, that's a container. Running a container image means that you're executing one of the programs that are stored inside the container image. In case of that Java application, the program you execute is the Java virtual machine. And a container represents the running processes of your application. It only exists at runtime. If there are no running processes, there is no container. And then there are two other important characteristics. Well, there are more, but these two are really important to remember. So first, the files from the container image are used to create a private file system for the container. These are all the files that the processes of your application will see. And then second, your application has access to a virtual private network interface with a local IP. And this means that you can always open a port and listen for incoming connections. And this is exactly what Cloud Run expects your web application to do. It wants you to listen on port number 8080 to handle HTTP requests. And in case you're wondering, that's including HTTP2 and gRPC bidirectional streaming that just launched in preview this week. But it has to be HTTP. You can't, for instance, start an SMTP server and expect that to work. It has to be HTTP. And also that port number 8080, it's a configurable default. So if port 8080 is like hard to listen to because I don't know you run Ruby or some arcane stack that doesn't let you change the port number, you can change it. And you might listen to this and you might think, HTTP, that sounds a bit insecure. Don't we want to use like something more like HTTPS, for instance? You don't need to provide that because Google's infrastructure handles that for you. And your traffic is always encrypted when it goes over Google's internal network. So besides the requirement for your binary thing, your application, to start an HTTP server that listens on the correct port, there's no restriction. You can use any programming language, using any dependency, using binary dependencies. I mean, you can even compile COBOL code and run that on Cloud Run. If you get it to run in a container, it runs on Cloud Run. And that's super powerful because containers can run anywhere. Right? So once you have your web application packaged in a container image, you can run it on Google Cloud, for instance. You can run containers on Compute Engine in a virtual machine, or on a Kubernetes cluster, or on a Cloud Run, which this talk is about. And on your local machine, you can use Docker or Podman, and both are container runtimes. So before we move on, here are the 4 key things you need to remember from this short review of container technology. A container image is an archive with files. It includes executables, system libraries, data files, and more. A container is a running container image. It represents the running processes of your app. And then a container image packages everything your application needs to run. If your application is a Node.js application, for instance, your source files are in the image next to the Node.js runtime. Cloud Run expects your application to start an HTTP server, but your traffic is always encrypted on the Google network. And the public endpoint, you will get that from Cloud Run, is HTTPS. So you don't have to manage SSL or TLS termination yourself. Now, after this short introduction, let's explore how to get your application to Cloud Run. When you deploy a container image for the first time, Cloud Run creates a service. And service is a very broad and non-specific word, but it means something very specific in Cloud Run. And the specifics will become clear during this session. But the first thing to know is that a service has only one active container image. And the second thing to know is that every service has that public unique HTTPS endpoint, which is managed by Cloud Run. And Cloud Run receives incoming requests to that public HTTPS endpoint. And to handle the requests, Cloud Run starts your container image on demand. And then it also makes sure to handle all incoming requests by starting more than one container if that's necessary. That's a feature called auto-scaling, and I will come back to that later in this session. So now, in case you're already familiar with Google Cloud, you're probably wondering right now if you can also route incoming requests from the global load balancer to a Cloud Run service. The answer to that question is yes. And in that course that I mentioned, I will come back to that in more detail in one of the modules. So I want to pause again here and direct your attention to the word service, because this is a key concept in Cloud Run. So you create a service to deploy a container image, and each and every service has a unique name and associated HTTPS endpoint. Like it will have a URL like the one I show in the slide, HTTPS hello, that's the name of the service, then a unique hash that's unique to your Google project, and then the Cloud Run domain. You can use custom domains if you want. And then as a developer, you interact primarily with a service resource to perform your tasks, such as deploying a new image, rolling back to a previously deployed version, and changing configuration settings like environment variables, scaling boundaries, very important with serverless, because, well, maybe you've read the blog post of the guy that like called his Cloud Run service from his Cloud Run service, and then that scaled up. Well, you don't want to know what happened next. Let's take a step back and look at how your container image gets to Cloud Run, because you're not sending it directly to Cloud Run, but you use Artifact Registry as an intermediary storage for it. And that's because Cloud Run can only pull container images from Artifact Registry. If you're used to hosting your container images somewhere else, like on Docker Hub or you're on a registry you host yourself, keep in mind that with Cloud Run, you'll need to push them to Artifact Registry first. What is Artifact Registry? That one's quick. Artifact Registry is a fully managed service in Google Cloud, and you might know this as Google Container Registry. And Artifact Registry is a universal package manager. You can also use it to host Java packages, Node.js packages, and containers, right? Then it's a Docker repository. And then Cloud Run can pull those from those. So let's take a look at how that works. As soon as you're ready to deploy your container image to Cloud Run, you begin by pushing, that's uploading in the container language, the image to the Docker repository on Artifact Registry. Your container image will have a unique name, a unique image URL in that repository, which you then can use when you deploy to Cloud Run. This means you hand like I show in the slide, the command line command you use. So you say tcloud run deploy image and then the image URL. And this means you hand the container reference over to Cloud Run, which then pulls the image from Artifact Registry. You can also do this, like I showed the command line example, but you can also use this, do this through the web console. And then finally, Cloud Run pulls the container image from the Docker repository. And to ensure that containers on Cloud Run start reliably and fast, Cloud Run will copy and store the image, the container image locally. And this internal container storage is fast, right? So this ensures that your image size is not a bottleneck for container startup time, because large images like your 4 GB Python with a lot of libraries, that loads as quickly as one small, fast, statically compiled Go application of 9 megs, right? So, and because Cloud Run copies the image, you won't get into trouble if you accidentally delete a deployed container image from Artifact Registry or change the tag, override latest, and then suddenly a different version is running. That won't happen, right? Because it makes a copy when you say deploy. So I've just explained, short intervention. I've just explained to you how to get your container image to Cloud Run through Artifact Registry, but I didn't even talk about how to turn your source code into a container image in the first place. And that's because that's another talk, right? And because you will do that with Docker, and some people really like it. And And that's okay. I mean, for some use cases, using a container-based workflow is great because it gives you a great amount of transparency and flexibility. If you build the container image, you have the power to decide exactly what file ends up in your container image and how it gets there. However, in some cases, that power is just too much to handle. Sometimes you're just looking for a way to turn source code into an HTTPS endpoint, right? Here's my code. Go ahead and deploy it and run it for me. I don't want to write a Docker file. So you will want your vendor to make sure that your container image is secure, well configured, built in a consistent way. With Cloud Run, and this is good, with Cloud Run you can do both. You can use a container-based workflow as well as a source-based workflow. And at the very end of the demo, I will show you how to do a source-based deploy. Now let's talk about auto-scaling and on-demand containers. What does that mean? Cloud Run starts your container to handle incoming requests. And multiple requests can be handled by a container at the same time, concurrently. And as long as a container is handling requests, Cloud Run will not shut it down, and unless something bad happens, like your application crashes. And I emphasize concurrency because, like, if you use a function as a service platform, it's one HTTP request per container exclusively. But on Cloud Run, it's just like a regular app. And then Cloud Run automatically increases capacity when necessary to make sure it handles all incoming requests. And this is a feature that's known as auto-scaling. And this is how that works, right? I show it on the screen. Every service has an internal HTTP load balancer. And this load balancer distributes requests over a group of available containers. And if all containers are busy, and Cloud Run looks at the CPU usage, for instance, if all containers are busy, it starts adding additional containers to the service. And as soon as demand decreases again, Cloud Run stops sending traffic to some containers and shuts them down. The number of container instances in a Cloud Run service is limited to 1,000 instances by default. Like if you need more, you can submit a request for a quota increase, and it will happily add more capacity to the Google data center, and you can scale out. However, over 1,000 containers can unleash a lot of load on downstream systems. And APIs such as your relational database, they might not be able to handle that, right? So you'll find yourself lowering that limit more often than increasing it to safeguard the stability of your system. Now, and this is good. When no requests come to the service for a while, Cloud Run shuts down all containers. It scales to 0, right? And a fresh container will start on demand as soon as a new request comes in. You might have heard of this. This is scale to 0, right? Cloud Functions do that. Cloud Run does that. And this process is attractive for economic reasons, as this means you're not paying for idling containers, which you are if you would have used virtual machines. But that's not the whole story, because the pricing model on Cloud Run is unique. You only pay for the system resources you use while a container is handling a request, with a granularity of 100 milliseconds. So most of the other compute products, such as for a compute engine or a Kubernetes engine, they charge for servers as long as they're running, even if you're not using them. And that means you're often paying for idle server capacity. I mean, you've seen this on a product, right? We need to over-provision a bit because, big demand might come this weekend, and let's add a few more servers. And then suddenly you're only utilizing 30% of your cluster. That happens more often than you'd think. I want to emphasize that you're charged for container time and not request time, right? So if your container can handle 50 requests at the same time, you're not paying 50x, 50 times for the same request, but one time for the container time. And then the price of the container time increases with CPU and memory. It can go up to 8 gigabytes or as low as 128 megs. And you can go up till 4 virtual CPUs. But then a container with more resources is more expensive. So now that you know, Yeah. So now that you know how the pricing model of Cloud Run works, it won't be a surprise that the lifetime of a container on Cloud Run is only guaranteed while the container is handling requests. So if a container is not handling any requests, Cloud Run can shut it down. I have a question about the cold starts. I'm going to come back to that after the demo, in the demo. So if a container is not handling requests, Cloud Run can shut it down. That doesn't mean it will all the time. And remember this, because when I answer the cold starts question, this will come back. So in fact, containers live much longer than you would expect if they're not handling requests. And that's because as soon as a container is handling 0 requests, the CPU is throttled to nearly 0. So this means that your application will run at a really slow pace, right? So say hi to that throttled turtle that Natalie mentioned in the introduction. So if your container is not handling requests, it will be throttled, and you're not paying for it, right? And that's one of the reasons that you will see a lot less cold starts on Cloud Run, because the idle containers are there. And you can even tell Google to keep a few idling containers there. You will pay like 1/10 of the price, but you won't have cold starts because they can switch instantly from throttled to not throttled and start serving requests, right? So cold starts on Cloud Run can be an issue, but a lot less than you would expect from the function as a service platforms. Because Cloud Run shuts down, and this is like if you're zoning out a bit because you like the droning noise of my voice, pay attention now, because Cloud Run shuts down and throttles idle containers. And this means you should complete all work before you return the HTTP request to the user, right? So if you are running any tasks that you want to complete in the background after returning an HTTP request, they might not complete, because it might be the last request that runs on that container, and it will be throttled. So it means that will be very slow, and then it might be stopped, and the background task might stop with it. And this is confusing sometimes. So I'm not saying that you cannot use background threads, right? You might be using some non-blocking IO thing and handle all the work in a background thread. That's fine. Just make sure to finish all processing before you return a request to the user. And that request, the solution is, if you do want to do backgrounds, because you sometimes you just want to return a request to the user and then do some work, right? The solution is to, turn your background tasks into HTTP requests. And there are 2 products on Google Cloud that help with this, Cloud Tasks and Cloud Scheduler. Cloud Tasks is like, hey, Cloud Tasks, can you execute this HTTP request for me? And wait to it until it finishes. And tell me if it succeeded or not. They're both well integrated with Cloud Run and Cloud IAM to make sure that only Cloud Tasks can actually call your service. There's another consequence to this concept of disposable containers that can disappear at any time, because you don't have any control on when they start and stop. And on a traditional server, you would store data directly on the server instance, and then it will be there, right? And on Cloud Run, that's not possible. That's not compatible with the runtime. So while the disposable containers on Cloud Run have a small disk you can write to, the entire file system is in memory and it disappears with the container. Well, this means you'll need to store persistent data in a downstream system, and probably if you're building a scalable system, you're doing that anyway. So you can store binary data in cloud storage, which is the blob storage on Google Cloud. Session data goes to that Redis thing. There's a managed version on Google Cloud that's called Memory Store. And your application data goes into that familiar relational database. So you don't have to use Firestore to build a serverless application. But keep in mind the scaling boundaries, because your relational database might not handle it. But you can just use Cloud SQL, the managed database on the Google Cloud, PostgreSQL, MySQL, MS SQL, and use that as a backend to your serverless application. So the key thing to remember here is that while you can write data to disk, you should be prepared to lose it. So if you want to keep it, save it downstream. applications on Cloud Run are portable. So portability is a valid concern for most application developers, and here's a couple of reasons why. So maybe your application needs to run in a geographical region where Google Cloud has no physical presence, and maybe you're also required to run it there and store your data there. Maybe as a developer, you want to avoid vendor tie-in and reduce the switching costs when you move to a different vendor. So applications on Cloud Run are portable in two ways. So first, there's containers. Well, you already learned from the beginning of this session that containers can run anywhere, which makes your application inherently portable if you don't start depending on something that's proprietary and only on Google Cloud, like Firestore. And the platform Cloud Run itself is API compatible with Knative. And that's an open source project that you can install on top of Kubernetes, the container as a service thing. And it's an entirely different implementation of the same API, the runtime API. So this means that you can take your Cloud Run application to Kubernetes, and you get the same runtime behavior and the same API to deploy your application, but it runs on your own infrastructure, maybe even in your own data center or on your cluster of Raspberry Pis in your closet. All right, so to summarize, before we head on to the demo, you learned about container images, how they are a package of your application and everything it needs. Your application can be written in any language, using any library and any binary. Cloud Run takes a container image and turns it into an HTTPS endpoint. It expects your application to listen to port 8080 or another one and respond to HTTP requests. And to deploy your container image, you create a service resource, and this is what the thing you will interact with primarily to deploy a new version, roll back to a previous version, and change configuration settings like environment variables, scaling boundaries. And the pricing model, finally, is unique because you are charged only for container time while handling requests. And a consequence of this model is that you can't rely on background tasks because they might not complete. Like, do your work before you return the HTTP request. Before I head into the demo, which is I will demo using the terminal, but there's two primary ways to interact with Google Cloud. One is the web console, and the other is the G Cloud terminal command line interface, which is great. But the web interface is a great way to get started, right? Because most products feature polished getting started wizards that guide you through creating your first resources. I mean, generally, the usage of the Google Cloud Web Console is a nice experience. It's almost like they invest time in developing a great UI. It's a great getting started experience. So, but the G Cloud command line interface offers a good user experience for those who like the command line, like I do. So you can write scripts, you get helpful suggestions if you mistype a command. So off to the demo. Quickly checking if there's more questions. The cold starts. I think I covered that. If it's still unclear, pop something in the comments. Again, I will get to it. Anyway, so hi, here's my demo application. It's a small Go application. So there is this, I'll zoom in this thing a bit. There's one Go file, an index.html template, and there's a Docker file that describes how I need to turn this Go code into a container image. Let's run it locally. Go run main.go. And where is my... Yes, I do want to allow that. And then if I refresh, there's this. Give me 1 sec. I made a script of the demo and I lost the screen. Finding it, found it. Yes, yeah. So run. Okay, go run main go. I did that. I'm on track. Excellent. Okay. So what's here? This is my little app, and it tells you metadata. It tries to get it from the environment. So first, it interrogates the place where it runs for the total memory, and that turns out to be 32 gigs. And my laptop has been running for 1 day and 7 hours. And there's a lot of environment variables, the request headers of the incoming requests. This will become more interesting when I deploy it to Cloud Run, because I will also interrogate the Google Cloud surrounding. So you will get like, what region am I deployed in? What's my instance name? What's my service account? That's there. So there's the red button. If I click it, it sends a REST API call, and that stops the instance. So let's do that. And then it refreshes the page. So REST request is sent from the page. It stops the instance, and after a short wait, it refreshes the page, and boom, the process is gone. And it also shows that in the terminal. Okay, with that said, let's go get this thing to Google Cloud. Yes, so remember, first I have to create a container image that goes through artifact registry as an intermediary storage, so, in a Docker repository. So I need to create that Docker repository first on Google Cloud. I'm using gcloud now, gcloud. And I'll show you like I do it when I first try to work with something on Google Cloud. So I will do gcloud artifacts. Okay, well, this it expects more of me. And then will tell me, okay, you can manage artifact registry container images. No, that's not what I want to do. I want to do repositories. Yes, I want to manage a repository. In fact, I want to create one. Repositories. There we go. Boom. It lets me create one. gcloud artifacts repositories create. This needs a location. Good. Okay. This means I can choose a Google Cloud region. For this demo, I will just use US, and it probably needs a name. Let's call this Cloud Run demo. And I need to add a repository format, right? Because there's Docker repository, Java, and NPM repositories. I want to have a Docker repositories. There we go. Repository. Always when people watch me type, I get very slow. Repository format, Docker. It will create it. Yes, it works. Good. All right. So I need to update my gcloud. I'm going to do that later, not now, because that's like trying to insult the demo gods. Now I need to build that image I have locally here, right? So I have a Docker file. So I will build that thing locally and tag it with the appropriate image URL, and then upload it to the repository that I just created. But let me create a few environment variables first, because I will need the name of the project. So project is now filled. If I echo it, echo project, with the name of the project, the Google Cloud project. On Google Cloud, you have a project, and you use it to organize all your resources. So you will generally put everything that belongs together in one project, and then you can easily connect the pieces. But connecting things from different projects is much harder. So it's a way to organize your system. Yeah, so and this is a subshell, just in case you're not a bash magician. So the output of this command goes into this environment variable, because the dollar thingy here. And then I'm creating another variable for the image URL, and that's this. So image is US Docker package.dev, that's the artifact repository URL, then that project. Remember how the project organizes everything? Well, this is where it happens. Then the repository name, I just created it, and this is finally the name of my image. Now, and I can now build my app locally. Docker build with a tag image, and then using the file Docker file. This is optional, I know it, but I want to spell it out and make it visible. It's building the app. So it copies all the Go files from the build context, and then it does a Go build. And then I use a distroless container for running. It's great, but that's a different session. Okay, now I need to push it to that the Docker repository on artifact registry that I just created. But first, I will need to tell Docker how to authenticate with Google Cloud. And I can do that with, I can have gcloud tell Docker how to authenticate. So that's what I'm going to do now. Gcloud auth, configure Docker. So please gcloud, configure Docker for me, Docker. To talk with the with the artifact registry thing on the location that I created my repository in. And I already did that. So you need to do this only once, right? So you don't have to do this every time, only once. Yeah, well, and then I can push my image, Docker push image. It pushed. Okay, so it's in the cloud. My container image is in the cloud. I can deploy my service. I will do that using gcloud run deploy image, and then my image URL, and then a name, hello world, and then I want to set it to allow unauthenticated requests. Wow. Authenticate. Copy and paste. People watching me type, that's such an. There we go. Allow unauthenticated. And it's creating my service now. So in seconds, I am able to show you how it looks like. I get a service URL. And this is that unique HTTPS endpoint, which is unique for every service in my project, and unique to, because of this thing, that's a hash of my Google Cloud project name. And yeah, so there, and you can use custom domains. So there it is. And there's more metadata. Is this readable? Yeah, I suppose it is. I will zoom in a bit. So the total memory of my instance is 265, no, 256 megs, and the uptime when it served and when it run this request was 0 seconds. Well, that makes sense because it was the first request, and Cloud Run starts containers on demand. I have one vCPU. It's running in the US Central 1 region. This is a service account, so every Cloud Run service has its own identity, and you can use it to give it permissions to access other Google Cloud services. And I have an instance ID. I made it a color because I'm now going to stop this container, and then the page will refresh, and a new container serves the request. So that's good, right? This auto healing is going on there, and I have some environment variables. This one tells me the revision because this was the first revision, and the service name. And then the headers for my requests. You will see a few tracing tokens there. Well, it's useful to look into that. But now I first want to show you that if I stop the container instance, a new one pops up and it serves the request. And then if I refresh the page, I will see that the uptime increases, right? So I will keep this humming for a while. So this particular instance, it served 2 requests, right? So if you go back to the pricing model of Cloud Run, that means I've probably paid for, it has a granularity of 100 milliseconds. So I've probably paid for 200 milliseconds of CPU time. But if I refresh the page now again, my container is running for 32 seconds already, right? So I've sent 3 requests. I've paid for 300 milliseconds of container time and the time it took to start up. But the uptime of my container, the full time is already 32 seconds. So if you were asking about cold starts, this is a part of the answer. Bye, Wietse. Thank you. Yes. So what else did I? Yeah. Let me show the how it works when you edit code and deploy, because I was raving about the developer lifecycle. So let's change inspect here to hello build meetup build tech talks. So what I need to do now is do a Docker build again. So I'm doing this locally, but you can do it in your CI, obviously. Building the container, then pushing it, Docker push, same image. It's probably pushing only the changes, but that's just one code binary, so that's the full thing anyway. And then I do a deploy again. Same thing. I could have also, if you look at how, like, I use an imperative deploy command, but I could have also updated the service resource. And it creates my second revision with my new version of the container image. And if I refresh the page, hello, build tech talks. So that works. That's actually a pretty fast turnaround. And then the revision name is now the second revision. All right, so I promised that I would show you a Dockerfile-less or source-based workflow. And here it goes. I will change the title again. I will make it say, look, no Dockerfile. Well, that's a weird word. Let's save it as look, no Dockerfile. Yes, and then I will remove the Dockerfile, rm Dockerfile. It's gone. It's really gone. There's no Dockerfile. And then I will do gcloud beta, because this thing is, well, it's in beta. It will probably become GA soon. And I'll do run deploy hello world, same service. And then I will just say source. And then this directory. So the dot here is the current directory. And this will take a while, because what happens now is that we'll take my source code in my directory locally, upload it to Google Cloud, and then figure out what to do to build it. So in this case, it will look at the directory, see a go.mod file, and figure out, well, this is going to be a Go application. So I know what to do. I will build this for you. And what I really like about this is that Google Cloud open sourced the technology behind that. So you can reproduce everything that happens now, that's happening now in Google Cloud. You can reproduce it locally, because you can use a command line tool that's called pack, and you can tell it to use the Google Cloud build packs, and then you can do the same thing, right? And you can inspect everything that happens and create your own version if you like. So it supports, out of the box, it supports Go, Python, Java, yes, Java as well. So that's great, right? But it takes a while, because, well, the whole process is longer. And on Google Cloud, it didn't have the convenient already cached thing, because I ran it before the demo. But it works, and it's hands-off, right? I don't have to worry about creating that perfect Docker file and making sure that it didn't run as root, and that there are no system libraries with security vulnerabilities in there. Well, let's refresh. Look, no Docker file. Hey, it works. That's good. I'm always happy when that happens. I guess that concludes my my talk. Yeah, make sure to connect with me, buy my book. If you follow that link, you will find me again. And I see Natalie popping up again. Hi. I think you're on mute still. Yes. Hi, Bart.
Hello, Wietse. Hello, Bart. Glad you're able to join us again. We are running a bit late now, so we do the Q&A with the three of us at the moment. So there were a few questions. Another question to Wietse. Answered most of them, but do you also have some advice on running a framework that has a life cycle like Spring on Cloud Run?
Yeah, so I'm having to guess now what the question is really about, because it has a longer startup time. Well, the thing with Cloud Run is that it starts sending requests to your running container as soon as it accepts TCP connection. So you'll better have to make sure that that's ready to handle that HTTP request on the moment you open a TCP port. What's your view on when one should go for a container-based solution and when to go for a serverless functions-based? Well, so Cloud Run does both. And it depends on whether you want to be responsible for turning your source code into a container or that you want your vendor to be responsible for that. I think that's the main thing. So some people like to have full control about that and want to create the perfect container, and some people like to not have the responsibility and have your vendor take care of it.
Okay, let's see. Before Bart so suddenly dropped off, there were also a few questions.
Yeah, that's true. I saw a question coming by. One was about, if you have a bad connection with your app.
That was just before you dropped off.
I thought it was very ironic.
Yeah, it was. Though I also like no Docker fuck a lot.
But okay. Well, it's better than Git fish. That happens also. I mean,
yeah. But to come back to the question, if indeed you are having low bandwidth or no connection at all, and you're making calls from your app to Firestore and you have the, let's say, offline capabilities enabled, then I'm pretty sure that it will take care of the connectivity issues and still succeed in submitting your request. Whether that also works when you're calling a function from your app, I need to check. I'm not sure. I don't think so, but again, not sure. So good question.
And there was a question, when you're talking about doing the summer average, that it was very slow. Sita asked, for those aggregations, you could also use a cloud function, right?
Well, actually, yeah, you could, but still you then transfer the processing from the client to the function if you continue to use Firestore. The best thing to do is, of course, to switch to a Cloud SQL, for example, so to a SQL solution, SQL database, which could be possible also with functions, because you can create a function that triggers on an update in Firestore and then puts that same data into tables in Cloud SQL. And then you could have a function that calls the Cloud SQL for your dashboard. That could be then a more neat kind of solution, sort of like a CQRS kind of thing. So that's indeed possible. But the drawback, of course, is that when you start moving into Cloud SQL again, is that it's not that serverless anymore as Firestore, for example. So you're paying longer per request, and also scaling up and down is organized differently and requires more intervention from you as a developer. So again, trade-offs, of course, there, and pros and cons. And of course, I had a mess with my laptop, and it just happened close to the end when I wanted to say, like, okay, if you look at the drawbacks that functions have, such as indeed the portability that Wietse mentioned, then you can have your Firebase hosting have a rewrite to a Cloud Run container, so to a Cloud Run service. So, and that's actually nice. That's in Firebase now since 2019. I checked. I finally now know what the year is, and it is indeed something you can you can map. So you can have your app have an endpoint, so slash whatever the service name is, and then go to Cloud Run. And that's also a nice way to overcome some of the limitations of Firebase there.
Okay, thank you. I don't know for which one of you is this question, but for a beginner in the cloud, where would you recommend to start?
Ooh. Will you take it, Wietse?
Buy my book.
Yeah, that's a good one. I agree.
Well, it's actually, it isn't like I'm the audience I'm aiming for is people that have experience building web applications, but not so much with container technology and not so much with the cloud. So I take care to explain those concepts and assuming that you are not familiar with cloud technology. And I think Cloud Run is a great way to get started with the cloud, and then you can advance to other more the lower in the infrastructure and go Kubernetes and explore more. I think that's a great way to get started. But if you're trying to get started with Google Cloud, they offer $300 of free credits. You can create a Google Cloud account, activate the free credits, and then you can start playing around. And if you use the web console, most products have great quick starts and getting started wizards.
And of course, I would like to add to it, focus first on your coding skills, because these technologies that we have here tonight are all focused on taking away, let's say, all the other burdens that you have, and so that you can focus on what's really important, and that's just the code and the data. So start with that first, and then indeed, I totally agree with what Wietse is saying. Buy his book, because I actually already saw a comment passing by on Twitter. I thought it was somebody said hey, he managed to squeeze in 5 years of cloud engineering into my 5 years of experience with cloud engineering into one book. So that's probably then a great way to start, right? It was a nice review.
Thanks. No.
Okay, let's do a last question. Is there a way to run Cloud Run on the edge?
Yeah, so no, because it's a managed product and it runs on Google Cloud and Google Cloud's data centers. If you want to have a Cloud Run-like experience, you can try to use Knative on the edge. That's the open source product that has a similar runtime behavior as Cloud Run.
Okay, I think we covered all of the questions. If I missed somebody, I'm very sorry. If you're quickly, you can draw our attention in the chat. If not, I will thank you both for your presentations. I enjoyed them both very much. Time runs when you're having fun. And well, thank you all, and this concludes our evening. Well, remember, we really love to share our passion for technology. Because of the pandemic, we are hosting these meetups completely virtual. But in the future, we were planning also to do live meetings in our office in Leidse Rijn, but also some virtual. Sign up on our meetup channel, and you will hear about the next meeting. And all sessions, these and the future ones, will also be shared on this YouTube channel and later to our Twitch channel. So subscribe if you don't want to miss a thing. And good evening. Bye.
Yep. See ya. Bye-bye.